On this channel, we provide useful programming information with practical code examples. This time, it's about shared array buffer in JavaScript. We will provide a detailed explanation of the basics of shared array buffer, how to use it, specific use cases, and security considerations. Enabling subtitles will make the code descriptions easier to understand. Shared array buffer is a powerful tool in JavaScript for sharing memory between multiple threads. Especially in combination with web workers, it enables parallel processing, making it effective for computation-intensive tasks and applications requiring real-time capabilities. Shared array buffer provides a memory buffer in JavaScript that allows sharing binary data between multiple threads, mainly web workers. A regular array buffer requires copying between the main thread and workers, but shared array buffer allows direct memory sharing without copying, thereby significantly improving performance. Shared array buffer has the following features. Shared memory. It allows multiple threads to work with the same memory space. Performance improvement. Since copying can be omitted, the overhead is reduced when processing large amounts of data. Thread synchronization. You can use it together with atomics to perform synchronization in order to avoid conflicts when accessing memory. First, let's look at the basic usage of shared array buffer. In this example, we create a 16-byte memory area using shared array buffer and treat that memory area as an int32 array. This memory buffer can be shared among multiple threads. The true value of shared array buffer is demonstrated when used in conjunction with web workers. The following code is an example of using shared memory between the main thread and a worker. In this example, the main thread creates a shared buffer and passes it to the worker. The worker can access this buffer to read and modify values. In this way, data can be shared between threads without copying. By using shared array buffer, both the main thread and workers can read and write to the same memory, enabling bidirectional update confirmation. Below is an example where the main thread sets a value. A worker changes this value, and then the main thread checks for the update. In this example, the main thread writes the value 100 first, and after the worker reads it, it rewrites it to 200. After that, the worker notifies the main thread, and the main thread reads the shared memory again to confirm the update. In this way, combining notifications enables bidirectional update confirmation. When using shared memory, one must be cautious of data race conditions and inconsistencies. When multiple threads access the same memory simultaneously, conflicts can occur. To prevent this, JavaScript uses the atomics object for synchronization. For example, to safely increment a counter with multiple threads, you can use atomics to prevent conflicts. Atomics.add increments the value at a specific index atomically and returns the new value. This operation is guaranteed to be conflict-free with other threads. Atomics load is also used to safely read values from shared memory. When using shared array buffer, there are situations where a worker needs to wait until a certain condition is met, and once another worker fulfills that condition, it needs to notify the waiting worker. In such cases, atomics wait and atomics notify are useful. Atomics wait blocks a thread until the value at a specific index in the shared memory changes, while atomics notify notifies waiting threads that they may proceed. This enables safe waiting and notification between multiple workers. However, atomics wait cannot be used on the main thread and is only available inside workers. On the main thread, a shared array buffer is created as shared memory and is converted into an int32 array with only one element. This single integer slot is used as a signal to synchronize between workers. Next, two workers are created, and each is assigned a role using the name property. Waiter, the waiting role, and notifier, the notifying role. Finally, the shared buffer is passed to both workers, and, on message, handlers are set up so that messages sent from each worker can be received. In this example, the waiter worker remains in a waiting state using atomics wait as long as the value at index 0 is 0. On the other hand, when the notifier worker changes the value to 123 with atomics store and calls atomics notify, the waiter worker will resume and be able to get the updated value. With this, efficient and safe waiting and notification between threads can be achieved. Shared array buffer is especially useful for the following use cases. Real-time processing. It is suitable for applications requiring low latency, such as audio and video processing or game engines, where data needs to be shared instantly between threads. Parallel computing. When processing large amounts of data simultaneously with multiple threads, using shared array buffer avoids memory copying and can improve performance. Machine learning. By parallelizing tasks such as data preprocessing and inference, efficient computation becomes possible. Shared array buffer is a powerful feature, but it also carries security risks. In particular, concerns about side-channel attacks like Spectre have temporarily halted its support. To mitigate this vulnerability, browsers have implemented the following measures. Site isolation. Sites that allow the use of shared array buffer will run in a process that is completely isolated from other sites. Cross-origin resource policy. To use shared array buffer, the cross-origin opener policy and cross-origin embedder policy headers must be properly set. For example, by setting headers like the following, the use of shared array buffer becomes possible. This prevents external resources from interfering with the current content and increases security. Shared array buffer is a very powerful tool for sharing memory between multiple threads. It is an essential technology for improving performance, and its effects are particularly evident in the fields of real-time processing and parallel computing. However, it also involves security risks, so correct configuration and synchronization are important. By utilizing shared array buffer, you can build more advanced and higher performance web applications. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. Thank you for watching. This channel provides practical and useful information about programming. Subscribe to the channel and let's deepen our programming skills together.